Okay. So I'm going to share video here in a second. Share my screen rather. There we go. Okay, so what you're looking at is the Unity project that we started messing around with last week. Hopefully, one good thing about the recordings is hopefully I can jump back in where I was with a little less embarrassment, because I know you guys can look stuff up, can look up the meeting from last week whenever you want, if you need kind of get the continuity retroactively. But actually, I'm not going to do that because I put a new version of the notes up, and let me actually. Okay. Yeah, so this is, Alex asked a good question. Well, just actually posed a point that it's a little hard to understand the kinematic slide that I had. And I put some pictures in that encapsulate my understanding of the Unity manual pages here. I don't know that it'll help a ton, but it should help some. So let me if I talk through them. So give me a minute. Let me just talk through these. So you remember what kinematics is about? Well, one of the things it's about is just the ability to manage multiple frames of reference. So what you're seeing here is actually these are just two-dimensional coordinate frames. So where my mouse is here, this is an x-axis, this is a y-axis. And then the blue arrow is not the third axis. So I realize now, as I look at it now with fresh eyes, it kind of looks like it is. It's not that. There's a point there. Okay, I'm doing everything two-dimensionally just to make it PowerPoint friendly. There's a point there, and that's going to be the XYZ that we're talking about. We're imagining using these API calls with that point. Okay, so for all of these calls, they're all about one frame of reference. One frame of reference has been used to generate an XYZ, but now we want to move it to another frame of reference. And the point of these calls is, well, there's three different ways to do it, depending on what you have in mind. Okay, so for the first picture here, where my mouse is, that point, that's an XYZ, just like any other vector. But here, what we mean is, our use is, we're using it to indicate a direction. Okay, so like roughly northeast, right? Okay, all right, so now when we say northeast and we give the XYZ, and now we want to use that information in another coordinate frame, if we just took that old XYZ for our new coordinate frame, because this coordinate frame over here is both smaller, it's scaled, but also more critically, it is tilted, right? It's turned on its side. So if I just use the same old XYZ, I won't get northeast over here. It's got to be transformed, and that's what transform direction will do for you. So it will generate the output of transform direction will be an XYZ that give the exact same direction, right? So whatever length that vector has will have the same length over here, and it will point in the same direction in space. And of course, to do that with a different coordinate space, with a different origin and coordinate system, we're going to need, in general, a completely different X, Y, and Z. So that's what I'm showing here, okay? That's the direction use case, okay? Now, the second case, which I think is the least likely one, but here you see one of these coordinate system is bigger than the other, maybe because one of these, the big one, let's say that's a giant truck we're driving around the scene, that's kind of his coordinate system. His is kind of scaled up to reflect the fact that he's big, and this is like a little car driving around the same scene. And here that dot kind of indicates a place where maybe like something that makes sense to scale, right? So he's trying to indicate like a place to park, okay? And of course he does it for the big coordinate system, he does it in a scaled up manner. And in the smaller coordinate system, so we want to, if we want to park in roughly the same place, we're going to want the orientation to be the same. So we want to do the same job as up above, but now we want to scale it down appropriately for our smaller size, being a small car. I'm not sure my story is is perfect, but it gives you some sense of what's going on. So anyway, point is, direction is now preserved, but length will not be preserved in vector versions of these function calls. And last but not least, so this is a very funny picture down here. Here we're using that point to indicate a location, right? So it's like, imagine two different countries who have two different, completely different grid systems that they've imposed on the world, but we're cooperating in a battle. And the big coordinate system country over here says, okay, here, I want you to attack over here. Here's the XYZ. Okay, so what do we expect? What we want is the XYZ that tells the smaller coordinate system people, it refers to, rather, the exact same point. If not, we're going to have a problem. Okay? So those are the three ways. So all these function calls have to do with having an XYZ from one coordinate system and wanting to get a corresponding XYZ for the other coordinate system. Hopefully unpacking it this way at least gives you some notion of some of the nuance, that that's not just a straightforward operation, that it actually depends on what the purpose of those coordinates is. Okay, so I'm going to stop there if there are questions.
So just like a use case for this would be like camera following for third person, so it always stays in the right spot, or like, I guess I'm just trying to visualize how we've used this or what the outcome of this would end up looking like.
Well, you're going to find with Unity, so the most typical use case for me is that a lot of function calls in Unity, a lot more than you might expect, always want world coordinates. And what's convenient to come up with most often are local coordinates, right? So like I want the gun to be rendered in my hand. Well, it's easy to say where my hand is in local coordinates because remember, X points out to the right. So, it's going to be the middle of my body, a little out in X. That's local coordinates, okay? But since Unity is going to demand global coordinates, then you're going to end up using one of these transform functions to do the easiest possible conversion. Does that help?
That does, yeah.
Okay. But there's no end of use cases for this stuff, and yet the reason I put this in is because I'm trying to keep the in-class demos as simple as possible, so you actually won't see these things coming up all that much, and when they do, it's sometimes a little bit implicit, but when you actually go and try to push the envelope, oh my gosh, right away you're using these calls all the time. All right, so I want to go back to physics now. So like most of the physics let's see, how far did we actually get? So this kind of puts on the table what I want to go over. I think I said maybe a few words about each one of these. I'm not sure, but probably at least a few more words is required. So triggers you've used in a tutorial, right? It's just saying whether an entity, it's to get information about when an object enters a certain volume of space. Kinematic bodies you've also seen. Where you've seen that is the haunted jaunt for John Lemon. When you set up his body, he was set up as he had a kinematic body component attached to him, and it was set to be kinematic. And the idea is we're going to be immune to forces as a kinematic object, but we will apply forces to other things. That's one of the things you could say about that. Hopefully, we did actually, now I remember, we did demo that in class, right? I put a block down, even when the block weighs a ton, it doesn't matter. When a kinematic body wants to move through it, it just moves through it and the block kind of has to get out of the way. Okay, now what I want to do is not seat, but set an initial velocity today, because that's where we had finished, right? I made the kind of the starts of a little cube firing gun demo, and we had cubes filling out into the world. We were using instantiate to construct them. That was working. They were getting placed in the right location. The only thing we were lacking is that they just kind of dribble off the end of the, as they're created, they just kind of dribble into the world. They don't actually shoot into the world. So to make them shoot, what we want to do is mess with their velocity. And that's what I want to do to finish off this demo. Then we'll move to another one. And I reshuffled the list of demo ideas over here to kind of put them in priority order. And we'll just kind of push down through them as time permits, through today, probably also through part of tomorrow. I think the check shouldn't be horribly long. So if the check gets pushed into the second hour, well, so be it tomorrow. Lab check I'm talking about. All right, good. All right, so to set initial velocity, all you need to actually do is grab the RG body, that's the rigid body component, and set its velocity. That will do it. So let's see, let's go back where we were. Let's just fire it up for a minute. I don't remember where we were. I'm left clicking. Okay, boom, boom, boom. And you see some things can fly up in the air, but that's actually just because of collisions, right? When I spawn a new box here, it gets spawned into, or it can get spawned into the middle of another box. So physics really doesn't like two objects to be inside one another. And the way it tries to resolve that is by applying some fictitious forces to each one of those to force them apart. That's what you're seeing. That's why the boxes look like they're jumping. So I get away from the boxes, you see, yeah, they're just dribbling into the world. Not what I wanted. Okay, so let's fix it. Let's go and here is our, I think this must be our code. Let's take a look. And let's find where that box is instantiated and let's mess with its initial velocity. This is the first of multiple ways you can do something that will affect the motion of bodies. All right, so let's see. So here we do our instantiate. Here we set it active. Okay, I'll just file in at the bottom here. So our new round is the name of our game object. So how do you get a component? Okay, do you know? Right. So this is a standard way these days. Get component, uppercase G, uppercase C, angled braces, and then the name of the component type, the rigid body. And then this is a function, so you'll want your parentheses. Okay, I think that should be right. Why are you complaining? Not rigid body. Can I not spell? Let's look at our cube in the inspector. Oh, lowercase b, because I can't spell. All right, so there we go. All right, so okay, so that gets the rigid body component, and the new information for you is, guess what? There's a property called velocity that it has, and you got to set it equal to a vector, and that will make it move. Okay, so right, but what's the vector? Okay, so what I want to do is, so this is a great example of something that could be complicated if I wanted the shots to come from where my right hand is holding a gun on the screen, but here, since I'm being flexible, I'm just creating the boxes right in front of the camera so we can do it the easy way. And the easy way is that each transform has a property called forward. And forward is, I believe, the world coordinates, which is what we need, the world coordinates of the straight ahead vector for any particular object. So this is, obviously this is something that happens enough that they made it super easy to go and get that direction. And once I have that direction, well, that's the direction the velocity should be in, right? So I'm gonna need a new vector 3. Okay, like this, and then we gotta set x, y, z, or actually, what would be the smartest way to do this? I wonder, let me just try to use forward directly. Because actually, there is no clone operator for these vector 3s as far as I know. So the way you actually clone one is you make a new one, and then you have to grab the x and the y and the z from the old one to make your effective clone. So let me just see if I can get away with just using the forward vector directly. If I can't, that's, you just heard what I'm going to have to do. Okay, so transform is my transform, I think. Forward is forward. Okay, and now we want to scale it by whatever we think is a good velocity. Okay, so I'll just let it be 2. That's 2 meters per second. This is not going to be a very dangerous weapon here, but that's probably for the best. Okay, so as soon as compiling is done, it'll probably let me bring up the project. I'm hoping, please. Okay, here we go. Let's go. All right, let's see if things are different. Okay, well, it's not a lot different. Okay, not a super convincing demo. So let's go in and add more velocity. How about 20 times 20 meters a second? Oh my gosh. All right. That looks a little more like it. All right. So you can see not only do they shoot out into the world, but now I can use one block to shoot another one off the edge. Maybe sometime it might happen, I think. You get the idea. There we go. Goodbye. Okay. Good. So box cannon. Okay. Any questions? Okay, now I have a question for you guys then. Right, so you might say, oh, that's fine. Instead of a box, I will use a 3D model of a bullet, and instead of 20 meters per second, I will use whatever the insane muzzle velocity is for my actual weapon. And there we go. I'll just use the same code. What do you think? Good idea? Bad idea?
Bad idea.
I'm going to have to make a Unity poll because I need practice. And you gave me the excuse, so. Oh, come on. What's it doing? Oh, this is weird. All right. Let's see. Okay. Let's see. All right. Give it a shot. I did it once before, but it feels incredibly awkward. Oh, didn't launch. There we go. All right, so we've got the bulk of the class thinking that it's not the best idea, and actually you are right. But why? I mean, notionally, you'd think it would be perfect for this. I mean, what governs bullet behavior? Physics. Here's the physics engine. Yeah, okay, well, the problem that you typically are going to have, unless you really go out of your way and do something kind of Herculean, I think, is that typically what happens is it takes a lot of, so collision detection, deciding whether one object is intersecting with another object is probably the single most expensive thing still today inside of graphical simulations. Even with all the fancy graphics. I mean, I'm not 100% sure. I debate it with Michael if he thought otherwise, but it certainly used to be the case, and I would guess it's probably still very competitive, okay? So collision detection is expensive. So what typically happens, the typical mode of using collision detection is you don't do the greatest possible thing. What you do is you just, for every physics frame, you would look where your bullet is, and then you would look at literally all the target objects, because that's what they would do. Of course, this is all optimized in terms of algorithms and data structures, so it's not as if they have to iterate through all these things in a stupid way. But effectively, it would check all the objects and say, am I inside of you? Am I inside of you? Am I inside of you? Okay? And then it would go on to the next physics frame. Okay? That's the background. So what does that tell us? Right? So here you got a bullet that's traveling at an extremely high velocity. What's likely to happen? You know, the hostile guy's right in front of me. I shoot him. Right? In frame one, the bullet is just about coming up to him. It's 5 feet in front of him. And then in frame two, because bullets are so fast, yes, it goes completely past him. It goes completely past him, and we're relying on the collision detection code to tell us when someone's been shot. And so what we see is, no, he missed, okay? And what actually happened is the bullet teleported through the target, right? So you can imagine this would be insanely frustrating if you gave users code that behaves like this. So that is not the typical way in which we deal with things that go very, very fast. Now, if there are cases for like bigger objects that also go insanely fast, this means, in my mind, again, it would be something interesting to talk about maybe another time. In my mind, there are just not good ways in a 3D simulation, for something like a missile, let's say. You really want it there as a 3D object. You want it to be moving. I mean, you see more than just a blur with a missile, I think. But you're probably going to have to do something fancy to make that work. Now, the good thing about bullets, I'm going to show you that the technique for dealing with bullets that is a lot more effective than trying to reuse our box cannon code. Okay. And I think this is pretty much what the majority of games would do. The bullet's still not going to be a real ballistic bullet. I'm not going to go through the effort to make it trace a parabola. I'm still going to treat it like a laser ray. So this is really just good for, close quarters battle, really, or just relatively crude simulations. But we have plenty of simulations across DoD where that would be an acceptable level of fidelity. Okay, so let's start talking about what our options would be. Okay. Let me just catch up with the chat here. Yeah, line of sight checking. Yes, that's the right idea. Okay. Yeah. So, right, that's where we're going to head. So the lucky thing about bullets is that, unlike missiles or really fast aircraft, is that they're tiny and you really can't see them when they're in flight. So the way we're going to deal with it is just not have a bullet. We're going to not have a bullet. So essentially what we're going to do is, when you point your weapon and you pull the trigger, what we're going to do is we're going to shoot a ray, in a mathematically straight line, like a laser beam. But actually even laser beams bend slightly in gravity. This is going to really be a mathematically straight line. Okay. And we're going to trace it out and see if it hits anything. Okay. And if it hits something, then the first thing we hit, we're going to treat it as if it has gotten shot, and it's going to, whatever our code's there to do. If it's a hostile combatant, we'll say he's been shot, or if it's an object, we'll say it absorbed a round. Okay, so that's going to be our strategy. Okay, so that's going to get us into this whole thing called raycasting in Unity. Which has got a lot of functionality to it. Physics.raycast. Yep, that's the thing. Okay, so we're going to want to do a raycast, and raycasting is really handy for a lot of things. Okay, so I'm selling it to you now as a simple model of shooting, but there are a lot of other uses for it. You can have the most peaceful simulation possible and find you can't get by without raycasting. Why? Because even stuff like, let's say you're going to build like a Minecraft kind of a world where your users basically, maybe they're going to be doing maintenance, right? So they're going to pick up tools, or they're going to pick up objects and move them from place to place and do stuff with them. Well, what does that mean? That means that the user puts his mouse over the object and he clicks, and somehow Unity has to realize what object the user meant. Oh, how is Unity possibly going to realize that? Okay, well, how are they going to realize that? You're going to cast a ray is what you're going to do. When you click the mouse, we're going to cast a ray in from that mouse pointer directly into the screen. We're going to see if it hits an object. And if it hits an object that the program knows how to do something with, we'll say, oh, the user has selected that object, and on we go on our merry way. Okay, so this stuff is hugely useful. It's also useful as the simplest possible model of target acquisition, or target detection, at least, right? How do we know if combatant A can see combatant B? Well, just draw a line between their heads, and if the line goes through a solid, then we say they can't see one another, and if it doesn't, we say they can see one another. There's really no end to the uses of raycasting. It's another one of those things. This is actually another type of collision detection. So it's not super cheap, but it has been very well optimized over the years. So we can get away from using it for a lot of different things. All right, so now I want to raycast from the center of the screen. Okay, so just for laughs, right? Raycasting is complicated enough, and I don't do it often enough that I always have to Google for it each time. So here we go. Raycasting from center of screen. Let's see what we get. Rays from the camera. Okay, so that's kind of useful. I don't think this is actually the right stuff though, but let's just take a look. Rays from the camera. Oh, this is not bad. Screen point to rate. Okay, now this is actually, they're giving a good code right here. This would be super good if you were doing what I just described to you, that someone's going to move their mouse, they're going to click, you're going to want to shoot a ray and see what object got hit. This is an awesome code sample for that. Now it's not perfect for what I want though. Okay, I think there's a different call that I have in mind, and I think it's maybe let's go to the next one. Let's see how hard it is to find it. It's got, like, I remember vaguely, it's got the word viewport in it or something like that. Let's see what we've got here. Okay, all right, so here we go. So you see this code sample here, all right? So you see them setting up a ray using this call. So viewport, your viewport is the square view into the screen that's provided to you. And I'm pretty sure it's got standard coordinates where 0, 0 is one of the corners, 1, 1 is the other corner, and then this would be the center of the screen. Okay, so this is pretty much perfect, I think, and this is actually very cute here too. Notice that if you go to the camera class, you can go .main and it lets you grab the camera without having to do anything more fancy to grab it. Yet another way to go and grab an important object in Unity. Okay, so I like this for all kinds of reasons. So I'm just going to copy this. Let's just steal it. Okay, but we got to start. We don't really have an app to work on yet. Let me get out of this thing. Let me go and let me do this. Let's go to let me save, Control S. Let me go to our project. Let me go to the scenes. Okay, and let me see if it'll just let me duplicate. This is the object shooting scene. Let's see if we can duplicate it. Oh, come on.
You can save as and just rename it that way.
Yeah, I'm gonna have to do that. Yeah.
All
right.
Oh, D work.
All right. Let's save as. Go to scenes. Okay, so this will be, we'll call this the bullet demo. Or well, let's say ray tracing bullet, ray traced bullet Unity. Okay, that looks sensible. Let's go with that. All right, so now we got our scene. Now let's double click on it to make sure we're in our new one and we don't clobber the old one. Okay, all right. So now what I'm going to do is we're going to need new code for this. I forgot where we put our code. On the controller. Was it in a container? Where was it? Plain cube. Well, this is awkward. Where in the world is the code attached to the application? Well, I'm looking in all the wrong places and it isn't there. Let me look back at the right place where it should be. Here we go. All right, so yes, so it's attached to the first person character, which is a child of the FPS controller. Okay, object shooter script. Okay, now I want to use a different, let's just start something new here. Some of this is actually useful. We could do another save as, couldn't we? Let's go. Save it as. Now, this is a good example here. This is going to be our ray traced bullet script. Ray traced bullet script. Now, when we first do this, if you think this is enough, it's a common beginner mistake. It's certainly not enough, right? Because you know that file names and class names go together in C# as in Java. So we've got to make this ray traced. Yeah. Change the first part of it, ray traced, bullet script. All right, good. Okay, so I'm not going to need a game object. I'm not going to need ammo for this. We're not making a bullet. Therefore, I'm not going to have to set it active. I'm going to want to shoot when the mouse button goes down. That part's the same, okay? But not so much anything else, okay? Now I'm ready. Let me kind of get rid of the rest, okay? So what do we want to happen when the user clicks the mouse and says, I'm shooting now, okay? All right, so let's go back to that code that I liked. Let me copy it again. Actually, I could probably take more than that. I'm going to take the whole bit. Let's take the whole bit of it and bring it in, and then we'll probably end up throwing most of it away, but there you go. Okay, so the first line I know I like. Okay, they're drawing a line. I don't care about drawing a line. I'm going to get rid of that. Okay, now this next line, raycast hit. You're going to need that, right? That's your object that's going to have all the information that's going to come back to you about what got hit when your ray got shot into the screen, right? That's the whole point. So we definitely want that. Okay, so then this is the ray actually getting cast. So we build the ray. That doesn't actually do the heavy lift of the computation. That happens in physics.raycast. Here's the ray, okay? We want it to go in the forward direction from the camera. That part is good. Here's where we give our hit information. Note the out keyword there. That's telling you that, yeah, even though it looks like you're passing something into the function, you're really not. That's just a placeholder for information coming back out of the function. Okay, and then ray length. Do we actually really need that? I don't know. Let's look at the physics.raycast. Let's just Google that and see what our options are. Maybe that's like a maximum length. I want to see if I can get away without it. Basically, I don't want to think that hard at the moment. Okay, let me do this. Physics.raycast Unity. What have you got for me? Always have to have a distance. Well, this one doesn't have a distance. Let's see, where are the prototypes for this thing? All right, let me just look up here. So it looks like layer mask is optional. And okay, the distance is optional. You see that here? All right, do you guys understand the same as me? Okay, so you see these first two arguments here are mandatory, right? You got to know where the ray is cast from. And, oh, actually, we're giving a ray. That's not exactly what we're doing, is it? Interesting. All right. I wonder if we're using a deprecated raycast or what. Okay, this will be interesting. I'm going to still try it. But I noticed here, so here's what I wanted to point out. You see, when you see a default value given, usually that means the parameter is an optional one. That's why there's a default value. Because if you don't provide a max distance that you want to trace your ray, then you see it will go out to infinity. And that's fine by me right now, right? But if we had some weapon with a limited range, you know, we might want to use max distance. Okay, but I'm not being that fiddly right at the moment. I'm going to try to just take ray length off. Let's see if Unity will be happy with that. All right, looks like it's all right. All right, okay, now I want to, okay, so you see, this says, if we hit something, do this. And if we didn't hit anything, do that. Okay, if we didn't hit anything, you know what? I don't need to do anything. So I'm going to get rid of that because I'm just going for a basic demo. Okay, so if you shot at the sky, That's as good as doing nothing for my app. Okay, tracing a line, yeah, I don't think so. Let's take a quick look at what a Raycast hit has in it. It's got all kinds of great information. You know, more than I've ever used. All kinds of stuff here about what collider you hit, how far it was, the exact impact point, the rigid body of the collider that got hit. So it's, oh, actually, that's actually great. You can directly get the rigid body. That's awesome. So that goes with what I want to do next. Okay, but one thing at a time. So right now, I'm just going to make like a little hit. We'll make like a little hit marker, and we'll just put it at the point where the bullet would hit. That's what I want to do, right? We're going to notionally shoot, and if our notional shot hit something, we're going to put a notional hit marker on it. Okay. All right. So you see that point would give you that point, the magic point where the intersection of bullet and object occurred. Okay, so let's go for that. So if hit dot collider is not equal to null, okay, that's fine. Then we go hit dot point is going to be my magic point. Now, what am I going to do? Actually, I'm not actually ready to finish this yet. I think what I want to do is I want to add in. I'm going to add in a public game object up here. Let's call it a hit marker. Okay, and we'll just move the hit marker to the location of the hit. Okay, so let's do this. We'll say hit marker dot transform dot position equals, let's just try this, equals hit dot point. Let's see if that'll work. All right, let's see. Okay, now we've got to wait for the compile. Now we're going to need we didn't even put the script on our first person controller yet. Let's kick out the old script here. That was the one from the shooter example. Kick that out. Let's add a new one in. What was it called? Shoot something, object shooter script. Okay, there it is. We're gonna need our hit marker. Okay, let's build a hit marker. Game object, 3D. Let's make it a sphere. There it is. Okay, let's scale it down a whole bunch. Okay, let's it's not going to be very visible, is it? Let's make it more visible. Let's make a material. Go to assets. You don't have a materials directory, that's a crime. Create folder. Okay. New folder, materials. Go into the materials folder, right click, create material. Okay. Let's go. Material. Okay, let's call it hit material. Here. Go in the inspector. Let's make it red. Like that. And actually, let's make it emit. So like a glowing red. All right. Okay, and now I have my hit marker. Let me go back to my shooter script. Here's my, why is it calling it ammo? Wait, that's the wrong script. Golly. Okay, let me get rid of that again. Component. What is our script called here? Ray traced bullet script. Okay, let's try again. I'll look for bullet this time. There we go. All right, so this is the right one. Okay, there, it's got a space for a hit marker. That's our sphere. And you see I did the wrong thing. You don't want to actually click on it. You want to just click and hold, bring it over and drop it over here. All right, so I don't know. Let's see if it does anything. Okay, so okay, you see my hit marker there? I don't know why oh, I didn't actually apply the material. Let's get back out. Okay, where's my material? All right. Let's frame my sphere, drag and drop. Okay, now go back in. All right, boom, boom. There it is. So wherever the last hit was, you see that's where the marker's going. Okay, you guys see how this is working, right? All right. Now, if this could already be enough, right? So you see that the hit has information in it. You know, if you're trying to kill a bunch of targets in your scene, you could use the information in that hit object coming back, the ray trace hit, to tell your code whether it was one of the targets that is valuable for points. And if it was, you could add to the user score, for example, right? You could use it to trigger animations. If you're animating a guy, you could use it to trigger his death animation so he dies. If something's supposed to blow up, you could use it to trigger a particle effect. We'll get to those in a bit. Okay, what I think I want to do, because we're doing physics now, so the only effect I want is I want to actually impart a force to that object. Now, if we were doing a box shooter, right, that's what we got. If I shot a box at the other box, you could see the target box will recoil. It's impacted. It shows it, okay? That's what I want. But I don't have any actual bullet that's impacting it. So how do I do that? Okay, so the answer is going to be, we're going to need to go right into we're going to grab the rigid body of the box, and we're going to apply an impulse to it. Now, I don't know if I think we talked a little bit about impulses there, those of you who took the JavaScript class with me, but let me just kind of summarize what's going on here. So an impulse is like a force. It's just a different abstraction than a force. Okay, so here's the thing about forces. The thing about forces is there's a lot of forces, especially with games and military sims, that act over a very short period of time, right? Like, how long does it take for a bullet to become lodged in you, or to go through you, or to impact your vehicle or whatever, and maybe cause it to bounce a tiny bit, right? It takes almost no time. Okay, but the thing about forces is, if you have a force, right? If I say I'm going to apply a force that's equal to, I don't know, the weight of the weight of a skyscraper to you, okay, how scared should you be? Again, it's one of those trick questions. If you have to ask, if you're a physicist, you say, oh, it's fine that you want to apply a force equivalent to the weight of a skyscraper to me. I'm not scared about that at all. How long are you going to apply that force? Okay, because forces always act over time. And if the answer is that it's going to be applied to you for some fraction of a nanosecond, it might be all right. You'd have to do the math. You might still get squished like a bug, but also it might be a gentle tap. It really depends on how much time. And if the answer if I tell you, oh, it's actually, we're going to apply it to you for 0 time, oh, well, then just go ahead. That's totally okay, because a force in 0 time does nothing. Okay? All right, now impulses are are an abstraction that's used for forces that are typically acting over short periods of time. So rather than tracking it over a short period of time and doing the math correctly, it's more convenient to just say, let's just say that the force acts over 0 time. Essentially, the logic works like this. If the bullet actually gets absorbed in a target over, I don't know, let's say 1/100th of a second, right? Then we could imagine doing the math. It's an integral. We all love integrals. Integrate the force, dt, over that. Figure out the amount of work. Work is what we call that. The amount of work that's done, that's what actually kills you when you're shot by a bullet, is the work the bullet does on you. Okay? Figure out how much work actually gets done. And basically what we're going to do is we're going to make the same change in the velocity of the object as if that force had actually happened over a 100th of a second. But instead of waiting the 100th of a second, we're just going to make it happen right now. Okay, that's an impulse. Okay, now in Unity, because they are kind of brother concepts here, it's the same function call you use for both. Okay, if you want to add a force, you do add force and you give it a force. If you want it to be an impulse, you do add force, you give it I called it force here, but it's not a force, it's going to be an impulse, and then you say it is force mode impulse, and oh, I lost the trailing parenthesis. I'm sorry about that. There you go. Okay, that's what we're actually going to do right here. Okay. All right. So let's deal with that. Okay, so all right. Let's go to our code here. So we found out when we were browsing the documents that hitmarker.rigidBody, it's called rigid body, no, not hitmarker, sorry, it's hit. Hit is our hit object. Hit.rigidBody is the rigid body of the object we hit. We can do an add force. Add explosion force, that's a new one, that looks tasty. Okay, gotta look at that later. All right, add force. All right, now we're going to have to give it a vector. This is going to take a little thought. So blah, blah, blah. That's going to be our actual force. And then we're going to say force mode dot impulse. Okay, and that's just, you know, if you went and pulled that thread to see like what is force mode dot impulse, it's probably like an integer. Like the force mode dot force is probably like 0, and force mode dot impulse is probably like 1. It's just a signal that you're sending to the routine to say that, oh, this is actually an impulse that I'm adding. It's not a force. Okay, now we have to go in here and actually put in a meaningful vector. And what would that be? I wonder if we just scaled our forward vector and use that. I think that would probably be plenty good. Let's try that. Grab our transform.forward because we're looking right at it, okay? And then we'd scale it in some way. Okay, I'll try just by a factor of 2 to start out with, and we'll go from there, okay? If this was something real, you'd have to do the math and figure out what kind of impulses would actually make sense. All right, so there we go. Oh, did you see it twitch? Boom, 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 it's working. All right, not enough force though. Let's go in here and just a factor of 10, easily done. Let it compile again. Oops. Oh yeah, there we go. And you see the hit marker actually doesn't attach to the object. I'll be asking you how I should fix that in a minute. You know, it just stays floating in the air where the object was. All right. Yeah. So I'm pretty happy with that. Maybe it's a little bit overpowered. Maybe I'll bring it down by a factor of 10, by a factor of 2, down to 10. Scaling factor of 10. All right. And what should I do about my hit marker? Well, there's got to be some way. We basically want it to be a child. We want it to be a child of the box, right? Well, I think after we add it, can't we go to the object? Let's see. So to get the game object, I think we got to go hit.collider.game object. So that's a little bit circuitous. I think that's right. Hit is a variable we use like a type. What's going on here? Oh, I'm not sure why it's not liking that. Let's see. Huh. I'm not sure why that's not working. I'm concerned about that. Okay, so I think maybe like add child, or maybe we got to do it the other way and set parent. Let's try the other way. Hit marker. Let's try again. Hit marker dot set parent. Ah, come on. All right. How can we solve this terrible, complicated problem? Let's see. Transform dot set parent. What's the deal? I have to explicitly grab the transform. Let's just try like that. I mean, transform is the parent. Oh, hit marker. Yeah, it's an object. I think this should work. And we probably need the game object of the collider. So we got hit.collider. That's the object we hit. And then we want to go up to game object to get its game object. Okay, I think that's what I want, but Unity isn't happy with me, so I'm gonna have to figure that out. Really? What if I explicitly go to the transform? Okay, and this maybe also needs to be the transform. Right, so we can go from any object to its transform. Right, the transform is its parent class, so we're basically going to use the object as its parent class type. Okay, that is much more ugly than I thought we were going to need, but let's see if it solves the problem. If it does, I'll be happy. And then we're out of time, so let's just 1 minute to talk about tomorrow. There we go. You see it's sticking now. You shoot at the ground, and it's there, shoot it there, and it sticks. Oh, look, see, sometimes it slides. It depends on where I impact the thing. Oh, I love that. Okay, all right, I'm feeling very self-satisfied now. All right, let's talk about tomorrow. So there's a bunch more things I would like to do. I had in mind to do like a bomb kind of a demo, maybe a lunar lander kind of a demo. Maybe I can get through those in an hour. I think your view of Unity physics would expand a lot with a couple more scenes. So I will try to do that if we can, but then at some point we've got to transition over and do some lab grading. So that'll be tomorrow. And any parting shots from your side?
Sure. Can you just pull up that ray trace bullets code
Yes.
we leave and then zoom scroll up a little bit? Or is it possible just to get posted? I think I'm like missing one character or line somewhere.
Yeah, I could throw it up on the site.
That'll work.
Okay. I'll probably zip it up just to be on the safe side. All right. Okay, thanks for your attention, and we'll finish physics tomorrow, I hope.
Thanks, sir.
Okay. Bye-bye.